Let's take a look now at some of these proving triangles similar using our three ways of doing this. Before we even start anything else over here, let's list our ways of proving them similar. We can use angle, angle, side, 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 or side, angle, side. And a good thing might be to start with each of these and decide ahead of time, well, which method are we looking for, and then see if we can use that method to say that these are going to be similar triangles. So in number one, we're looking to see if this triangle is similar to this one. So let's see what we've got. We've got a pair of sides, we've got another pair of sides, and nothing else. So that's all our given information. Now let's look for any kind of sneaky information. Here's what I mean by that. Notice these two are vertical angles. So angle FKE is going to be congruent to angle LKM because those are vertical angles. So that's the kind of thing that's there, but they didn't necessarily tell you about. Other things to look for is if you have a set of parallel lines, like for instance if this was parallel to that, we could say that alternate interior angles were congruent, and so on and so forth. So be looking for any extra information like that. But as for this diagram, that's it. We know the vertical angles are congruent. So we have a side, an angle, and a side, an angle, and a side. So if these are similar, it will be because of SAS. Now the other part of that, we know the angle's congruent, and we know it's included between the two sides. Now we just need to see if the sides are proportional. So let's look at this. We always want to pair up corresponding sides. So if we look, there's a bigger side and a smaller side. So the bigger side has to go with the bigger side down here, smaller side with the smaller side. And we can go either direction we want. It's usually easier to go from the smaller to the bigger one. So in order to go from 5 to 10, we need a dilation with a scale factor of 2. So our scale factor for this side would be 2. If these are proportional, we have to use the same scale factor over here. 4 times 2 would be 9, and so that is not going to be proportional. So we would say that these are not similar because the sides are not proportional. All right, now on number 2, we can look at this and we can see what information we have. And the information we have is about all the sides of these two triangles, one here and one here. Now one thing I do want you to notice is that this 33, the distance from there to there, is not the distance along this whole side of the triangle. We should figure that up real quick. This whole side would be 33 plus 11, or 44. Same thing over here. This longer side would be 24 plus 8, or 32. So we know we're going to use side, 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 and now we just need to see if they're proportional. So let's start with this side because it's easier to see. On the smaller triangle it's 9, and it's going to 36. So that would be a scale factor of 4. So now we need to see if that same scale factor is used for all the other sides. Well, the side that was 11 became 44, so that would be a scale factor of 4, so that checks out. Our side that was 8 became 32, so that's a scale factor of 4 as well. So these sides are proportional, and we can say that these triangles are similar by SSS, and that we would have triangle KLM is similar to triangle, and just as before, we have to match up these parts. So K corresponds to K, L corresponds to D, and M corresponds to E. So triangle KLM is similar to triangle KDE. All right, in our final example, we just have two angles congruent. So we know we're going to use AA, and there's no more work to be done here. There's one set of congruent angles, there's another set. So these are similar by AA, so that was easy enough. And now we just need to set up our correspondence. Be careful on your angles here. Triangle QRS is similar to triangle, well, Q is our 63-degree angle, so that's going to correspond with F. R is our 53-degree angle, so that's going to correspond with G. And then our remaining unknown angle would be H. So we can say that triangle QRS is similar to triangle FGH. And with that, we're finished.